Hi, my dear students. Welcome you all. Welcome to Unacademy. This is your Boolean sir. As we are continuing our uh, Digital Barfi Series, we are continuing the next topics. And so we are planning the Boolean Algebra we have completed. Now we'll continue the logic gates. चलिए आज का सेशन हम शुरू करेंगे. इसके पहले हमें बढ़िया से बढ़िया ऑफर आए आपके लिए. So in for GATE 2024 के लिए you can have a look at now here. In GATE 2024 you can see. So here tops 7 AIR 1 ranks from Unacademy students only. Now it's time for you can start your serious preparation with the Unacademy to achieve your dream goals. Right. So you can see now different branches. Electrical may be I, CSIT may, EC may, and CH and IN, PI, NM. All these different branches. The toppers from Unacademy only. Now it's time for you can start your serious preparation with the Unacademy to achieve your dream goals. So we are launching the new branches, new subjects we are launching. To enroll for it, you can use my referral code of BVRD. So there are new batches for 2025 के लिए and 2026 के लिए you can see now here. 26 के लिए नया बैचेस भी शुरू होने वाला. नवंबर 15 से शुरू हुआ and नवंबर 30 से हमने नेटवर्क शुरू होने वाला for 2026 2027 के लिए. Right. There are new batches you can see for 2027. And another biggest thing is the Unacademy GATE scholarship test. The test is going to conduct on November 25th, 4th at 11 a.m. It's time. So now you can start your serious preparation with this. You can achieve your dream goals. इसीलिए here you can get the laptop भी मिलेगा, smartphone भी मिलेगा, tablets. And so you can get the family vacation in 5-star accommodations. And कम से कम आपको गेट फी का रिफंड भी मिलेगा. This is the least case आपको मिलेगा. You can enroll for this Unacademy scholarship test and you will have a बढ़िया से बढ़िया so ये exciting rewards आपके लिए इंतजार कर रहा. Laptop, yes, tablets and smartphones. Do enroll for this Unacademy scholarship test immediately. Don't make any delay. The date is on November 24th at 11 a.m. And the list of books Unacademy GATE iconic subscription students can get. These are the list of books for electrical के लिए. All the books now here you can see now electromagnetic fields, network theory, measurements, and digital, machines, power systems, and power electronics, analog, signals and system, control system, maths, aptitude. All these books are delivered to your home address within 15 days of your subscription. Next, there is a list of books for EC के लिए. You can see now here EDCI, network theory I, electromagnetics, analog electronics, signals and system, control system, communication system, digital electronics, and engineering maths and aptitude. सारा के सारा books आपको मिलेगा within 15 days of your subscription. And keep in mind, ये books केवल Unacademy iconic subscription के लिए की मिलेगा. ठीक है. चलो आज का सेशन हम शुरू करेगा. So without any delay, so here let's start our session. Last class we have discussed all these problems, right? So chalo let's continue. Remember the student who are following who did at the previous classes, you can check the previous lectures. You can get this. Up to 50 problems we have completed. Now let's continue the next problem, 51. Take this problem. The logic circuit shown in the figure can be minimized to what? If I call this is my F, you can tell me now here this is X bar, this is X plus Y whole bar. This is the NOR gate now. So finally what I'll get now, F is equal to what I'll be now here, X bar plus X plus Y bar whole bar. So finally F will come to be what I'll be now here. X into what we can say now here, X plus Y. So simplify this thing, what will come here, X plus XY. If I take the X common, will come it as 1 plus Y. Now 1 plus anything is 1 only. So finally F is equal to X. So this is X and this is F is equal to X. So option next. In the figure shown, the it will be one's complement of a. One's complement of a आने के लिए क्या देना पड़ेगा? X, y will be given as 1. अगर y is equal to 1 दिया तो, so what we can say, tell me now here, it will come it as what, tell me now here, either A0 bar and this is A1 bar and this is what, tell me now, A2 bar मिलेगा. So that means which is nothing but what is one's complement only now. So y value क्या देना पड़ेगा? 1. Next, the minimized logic circuit is. Yeah, tell me the minimized logic circuit in this case. Now, if I call this is F, tell me now here हमको क्या क्या मिलेगा? You tell me. इधर हमको X bar मिलेगा, इधर हमको this is Z bar मिलेगा. And what about here? You tell me. This is X, Y bar, Z. The whole bar. Check it. NAND gate na. So finally what I can say now, F is equal to what, tell me now here, X bar plus X, Y bar, Z whole bar plus what, tell me now here, Z bar. So what I can say now, F, it will come to be a what, tell me now here, X bar plus X bar plus Y plus Z bar plus Z bar. So that is F is equal to what I can say now here, X bar plus Y plus and this is Z bar. So that is F will come to be a what I can say now here, X, Y bar, I can write it as Z ka whole bar, I can say. So option you tell me now here, option D. Now tell me the expression now, the circuit shown in the figure, following figure realizes the function. What the function of the realize, you tell me now here. This is given as AB bar and this is what, tell me now here, AB bar into C whole bar and this is what, tell me now here, DE bar. So finally what I'll get now here, the NAND gate now here, AB bar into C whole bar into what we can say now here, DE bar whole bar. Tell me now what I'll get now here. This is AB bar into C plus what I can say now here, DE. Yes. So constant option you can see now here. This which we can write it as A bar plus B bar into C plus DE. So what's the option you tell me now? Option A. Next. The output of the logic circuit is. Now you can tell me now this is B, so will come to be A plus B bar. And this is what we can say now here, B plus C. And this is what I can say now here, A plus B bar into BC. And here this connection is from where now? B say na. Okay, this connection is from B say. So that is why it will come to be a what you tell me now here, A plus B bar into BC into B. D1. So then it will come to be a what, tell me now here, ABC plus 0. Check this thing, option to 9. Sorry किया ना. Yeah, this is what now, B plus C now. Why B into C? Why though? Yeah, this is what I will have, B plus C now. So here this is what you tell me now here, B plus C into B. अभी सही है. check करो. Now if I multiply these two here, so what I'll get now here, this is AB plus B into B bar is 0 and this is B plus C. Then Y it will come to be what we can say now here, AB plus, this is ABC. This is given us what we can say now here, Y is equal to AB. Option C. Next. When two logic gates with open collector they given are tied together, so here they asking what will be the output. So at this connection you can treat this as we have there is some AND gate is there, into the AND gate is present. Now you can tell me the output what will come. Here this is A plus B bar. Here it will come to be what is now C plus D bar. So what we can say now, Y is equal to A plus B bar into C plus D bar. Then Y it will come to be what we can say now here. Yes, so this is A bar into B bar into C bar into D bar. So the option B. C is not correct. Okay. Next one. Yeah, tell me now this output here in this case. So this is nothing but हमारा बर्फी है ना. So हमारा बर्फी है तो so which gate you tell me now here? XOR gate बर्फी remembered. So बर्फी you tell me now here. कौन सा बर्फी here? Please what tell me now here? NAND बर्फी. What is बर्फी here? Tell me now NAND बर्फी. So this is what will come. The F is equal to what tell me now here? A XOR B. Now what will be the output? Yeah, you see this thing here. So here this bubble, now this bubble, I'll remove here, I'll place a bubble here. Remove this bubble, place the bubble here. Then remove this bubble here. Now you see there's this option, exactly D, you can check it. Next one. Now you tell me here. So this is what tell me now here, A plus B. And here this is C. So what will come here? This is A plus B into C ka whole bar. And this is what we can say now DA. This is DA bar. So what will be the Y value? Tell me here. This is A plus B into C whole bar or into what we can say now here DA bar whole bar. So ये तो NAND gate ना. Now you tell me now here what I can get. This one. It should be equal to A plus B into C plus this is what I will now D. Check all of you. So कौन सा option है? Option A. Next, the output of the given circuit is now this is X. This also X only. So what is the X? XOR with X is a 0. So this is 0. This is X. What is the 0 XOR with X is a buffer, that is x, and this is x. What is this thing? X. XOR with x is what? Tell me 1. So this is equal to 1. Now you can see this thing. Y. Yeah, tell me now expression y will be given as what? Tell me now here. A plus. Here is A bar, B. This is C bar plus C. Check karo. Now this is NAND gate now, so this bar. Then y is equal to what we can say now? A plus what? Tell me now here. A plus B bar plus C plus C. And simplify C, what I will get now? From this, which we can see it as what? Tell me now here. A plus B bar plus C. Now this, which we can also write it as A bar B C bar whole bar. Check it now here. Tell me. A bar C bar, yes, that option B. Next one. The circuit shown in the figure realizes the function. So here this is what we can say now. This is A plus B whole bar, and here it is A plus B bar plus C whole bar, and here this is D plus E bar. This is what? Tell me now here. D plus E. Now this is output. You tell me now here. Y value will come to be a what? Tell me now here. A plus B bar plus C whole bar, okay, plus D E whole bar. Simplify here, what I will get now here. This is A plus B bar plus C whole bar, again whole bar, into what? Tell me now here. D bar. So then Y value will come to be a what I can say now. This is A plus B plus C. Yes, into what we can say. Tell me now here. That is D bar plus E bar. So कौन सा option you tell me now here? Yeah. Next one. The logic operations of two combinational circuits F1, F, figure 1, figure 2 given. Now the relation between these two we are going to see. Let us say this output is F1, this output is F2. Let us talk about F1 and F2 relations. Now, so here this is what? Tell me now here. X plus Y bar whole bar, and this is X. So you tell me now what is this F1 is it? That is X plus Y bar whole bar, again whole bar. So this F1 will come to be what we can say now here. X bar into X plus Y bar. So then F1 will come to be a what? Tell me now here. X bar into Y bar. So this is F1 we got. Now let us find the F2 now here. What about this F2? This is X Y bar whole bar. This F2 equal to X bar plus Y. You tell me what the relation between F1 and F2. Is it complementary? No. Is it identical? No. Dual also no. So these are entirely different. There is no connection between these two. Right. Next. If the output of a logic circuit is 1, when all its inputs logic 0, then the gate is. I think this type of problem so many times repeated. A and B, the output Y value. What they're saying here, output is what they're saying here. 1 they're saying. So when all its inputs are 0, 0. When all the inputs are 0, 0, output will be a 1. This can be happens in which case you tell me now here. NAND case will happen. And that is NOR case will happens. And what else you tell me now here? That is XOR case also will happens. So what will you tell me? NAND NOR is there now. Next. How the inversion achieved using XOR gate? Inversion kaisa hoga, you tell me now here. XOR gate 1 XOR with X will commit as what will be X bar. Now, if one of the input is 1, so that we can get the inversion here, giving input to one input line and logic 0. No, giving input to one input line and logic 1. Yes, exactly. So this is XOR gate. What I can do here, the input. This is the input I given. The other input I given as 1. So what I will get to tell me now here, X bar milega na. It is option C. Next. The circuit shown below is functionally equivalent to. What is the output? Yeah, tell me now here, this is A bar. This is what tell me now B bar. So what is this thing here? A bar into B bar. Now this is A and this is B bar. This is A B bar. Whole bar, sorry. This is also whole bar, no? NAND gate. Again, F. That is also NAND gate only. So what I can say now, this is A bar, B bar, whole bar into what tell me now here? A, B bar, whole bar, whole bar. So what will the F you tell me? A bar, B bar plus what tell me now here? A, B bar. So means B bar we have taken common. So B bar will come now. सही किया ना. There is no B bar na here. There is B only. So this is B only. So this is what will be now A bar B whole bar. See what I will get. That is F is equal to what will be now here? A bar B bar A B bar could be given as what I can say now A bar B plus what terminal here A B bar. Yeah, this is nothing but XOR gate only na, and this is A XOR B. So option C. Next one. The output which is equal to 1 for what cases? This is 1. So mean this is what will be now here AND gate. When the output of AND gate is 1, when all its inputs are 1. So means this is 1, this is 1, this is 1. Means C must be equal to 1. And this is which gate you tell me now? XNOR gate. When the output of XNOR is 1, both inputs are equal. So this means B must be 1. And this is which gate you tell me now? XOR gate. Huh? And this is which gate is a XNOR gate. So A must be 0. So means what we can say here, A is equal to 0, B equal to 1, and C equal to 1. So the option is D. Next one. Circuit shown below is to be used to implement the function. The values are to be selected for I and J are. The values. What could the values selected for I and J? Yeah, tell me now here. This is, here it is I plus A. And here this is A bar. So this is J plus A bar. What is the Z is equal to what? Tell me now here. I plus A into what? Tell me now here. J plus A bar. We multiply. We can apply the T2. We can try. Agar T2 we try, so this is 1, 2, this is 3, this is 4. T2 try किया तो, so tell me now here 1, 4, 2, 3. So this is AJ plus what? Tell me now here A bar into I. So I have to implement what? Tell me now here the function I need to implement this as Z as what? Tell me. So A bar plus B I need to implement. So इसके लिए क्या करूँ इधर? So this Z which I can say A bar into 1 plus A into B चलेगा. Okay. Yes. Mengel property किया तो. So by comparison, what I can say now here, I must be equal to 1 and J must be equal to B. I1, J must be B. Option C. Next. Which one of the following logical operation is performed by the digital circuit? Tell me now here, this is the expression Y if I say. What I'll get here, this is A, B bar. And this is what? Tell me now here, A bar into B. So what will be the Y value? Tell me. This is A, B bar plus what? Tell me now here, A bar into B. So this is what? Tell me now here, A XOR B. Next. What is a Boolean expression A XOR B equal to what? Tell me direct problem now here. A bar B plus AB bar. The output of the circuit shown in the figure is equal to. So you tell me now here, this is bar is there here. So here this is what? Tell me now here, A XOR B bar. That is nothing but what? Tell me now here, A XOR B. And this is A XOR B bar, which is nothing but A XOR B. So what is the output? You tell me now, output Y, which is equal to A XOR B XOR with what? Tell me now here, A XOR B. So what I'll get this Y value? Tell me 1. So then tell me now here, the output X is what I can say. This is AB bar and this is CD bar. This is EF bar and this X. So this X is equal to what? Tell me now here, this is AB bar into CD bar into EF bar whole bar. I'll get to tell me now this is AB plus CD plus EF. So the option, and we can do here, you know that two level, we have discussed this thing now, two level and our logic. Level and our logic, which is identically equal to what I can say here, two level NAND logic. Next one. Now, which of the following gate is redundant? Now you tell me now, here it is W bar. And this is what we can say, W bar into X. Here this is X bar. This is what I'll be now, X bar YZ. So finally what I'll get the CF, you tell me. W bar plus W bar X plus X bar YZ. Now, so that is F is equal to, we can take W bar common, that is 1 plus X plus what element of here, X bar YZ. So that is F is equal to what element of W bar plus X bar YZ. So that means here you can see now this term is not required. Now this gate means gate number 3 not required. So here this is the redundant term here. This is a redundant term that is not required. Next one. The Boolean expression is to be realized using only two input gates. Which are the gates are? So they have implemented this one by using only two gates they are using here. That's what they're saying here. They given the max terms, are what are now 0, 5. Here you tell me now how I can write this expression where this X is equal to what, tell me now 0. So 0, how we can write, to tell me now here 0, 0, 0. 5 means what, tell me now here 1, 0, 1. So we can write the 0 as P. So this will be a P plus Q plus R into what I can say, tell me now P bar plus Q plus R bar. US form now. So this, I'm arranging this as P plus R plus Q. Next one is P bar plus R bar plus Q. This whole thing I am taking as 1 and this is 2. No. Better, I will do it like this. Now you tell me this is 1, this is 2, and this is 3, this is 4. We are applying it as what, tell me now here. Now T1 we are applying. And what will be the T1, you tell me? 1, 3, 2, 4 Q plus what, tell me now here, P plus R into what we can say now P bar plus R bar. And that is X is equal to what we can say now Q plus, we can apply the T2. That is, yes, P R bar plus what we can say now here, P bar into R. P bar into R.
that is x is equal to what we can say now q plus I can say this as p xr with r. So this is xr again, r gate से हो जाएगा ना पूरा काम, need of any additional gates. The Boolean expression for the output of the below logic is. What is the Boolean expression? You tell me now here. This is A XOR B. This is C. So what will be the expression? You tell me finally. A XOR B. Yes, into C ka whole bar. So I'll get to tell me now here. A XOR B plus what will be now C bar. So this y should be given as A x naught B plus C bar. You can tell me now y. So what will be the y now finally? Be given as x naught A bar B bar plus what tell me now here A B plus C bar. So option A. Next. According to De Morgan's second theorem, tell me what happened. De Morgan's law is what? NAND gate is equal to bubbled AND gate. Yes. NAND gate is equal to what? Tell me now, bubbled gate only na. Bubbled form we can write. Yes. NAND gate is nothing but bubbled OR gate. Isn't it? So here, what is the bubbled OR gate? You tell me. I say A, B, and what I will get this output now? Y is equal to what? It will come to be A. What you can see now here? A bar plus B bar. So then this is Y. It should be come to be A. AB whole bar. This is a NAND gate only now. NAND gate is equal to bubbled OR gate only. Next, if x bar y bar equal to 1, that means they given x bar into y bar equal to 1. That means what I can say now, x plus y whole bar, which is equal to 1. And what I'll get now here, x plus y is a 0. X plus y is 0. Now we can verify कौन सा option satisfy करेगा इसमें. Now check the option A. LHS, RHS will verify it here. So what is LHS? You tell me. LHS. This x plus y is equal to 0 means x must be 0 and y must be also 0. No? Tell me now LHS. We have verified. How much will get the LHS value? X value how much here? So that is 1. So this is 0, 0. Yes, 0. So LHS value 0. Whatever the RHS term here. So this is x 0, 0. Yes, satisfy. LHS is equal to RHS. So first one will satisfy. Next, can you verify the remaining options also? Now, what is the LHS? You tell me here. 0. So this is Z bar will come. Z bar will come. It is 0. So this LHS is the Z bar. And whatever the RHS value, tell me. 0. So Z bar. Yes, OB satisfy karega na. This is also correct only. Next, what about the option C? You tell me. Option C satisfy hoga kya? Check the option C. So what the LHS value? Tell me. So 0 plus 0. So that is 0. And whatever the RHS value, tell me. X value 0, yes 1. So not equal, not satisfied here. Next, option D, x bar means what? Tell me now. X is equal to 0. X bar is 1 into this is 0 into what? Tell me now, 0. So this is 1 now. So this also not satisfied. So A and B will satisfy. Next one. The Boolean function they given. So what will be the min term they asking? Yes, good problem. Possibility to do a mistake, this type of problem. And they given f given. So min variables given as what? Tell me now, x3, x2, x1. So here these variables are different. So in those cases, we cannot directly apply the AND gates analysis. We should multiply one by one. We have to multiply. Let's see. What is the f? You tell me now 3. How we can write the 3? You tell me now here. That is x3 bar. And that is x2. And this is x1 plus 4 x3, x2 bar and x1 bar. 5. So that is x3, x2 bar, x1. Next, whatever g you tell me. So this is x4, x3, x2. Yeah, you tell me now what will come. 1. So that is what we can say now here, x4, x3 bar, and this is x2 plus. So this is x4, x2 and x3. No. x3 and x2 bar plus 7 x4, x3 and x2. Now what they given now here, h, they given the function. So here h is given as, it contains the terms as what? Tell me now here, variables are x4. It contains variables are x4 and x3 also, x2 also, x1 also, which is equal to what? You tell me, product of these two. We'll multiply now here. If I multiply this with this, x3, x3, here we have what will come here, x4 bar, x3 bar, x2, x1 plus. If x3, x3 bar, so this term 0. Next, this and this also 0. Plus, now this and this, x3, x3 bar 0. Plus, this with this, x3, okay, so this is non-zero. x4, x3, x2 bar, x1 plus this with this, x2 bar 0. Next, this x3 bar 0. Next, x3, x2, here non-zero. x4, x3, x2 bar, x1. Next, 0. Yeah, you can see now finally what we have. Tell me now h of x4, x3, x2, x1. It should be equal to what I will get. You tell me finally. This is x4 bar, x3 bar, x2, x1 plus x4, x3, x2 bar, x1 bar, x4, x3, x2 bar, x1. Yeah, you can tell me the min terms now here. This is a 3. Here is a 12 and this is 13. So finally min terms. Tell me now here 3, 12, 13. Next one. Yeah, I think the same problem we repeated. Just now we did, I think so. I value 1, j value b. Hmm? Next. Yeah, tell me in this case. And here, how these two are, tell me now, parallel. So it will be a plus b now here. And these two also parallel. So it is c plus d into e. So finally, L is given as what we can say a plus b into what element of c plus d into e. Option A. Next. Yeah, the truth table they asking. Hmm. In the truth table, here what I can say, this is now here x y bar. This is x plus y. Okay, finally z, it will come to be a what element of here x y bar plus what element of here x plus y. So it will come to be a what I can say now here x bar plus y bar plus x plus y. It will equal to 1. So option A, x plus x bar is 1 now. Next, output of XOR gate. Note the output of XOR gate if A and B are the inputs now. What is this A XOR B equal to what? Tell me. A bar B plus what? Tell me now here A B bar. This option is not there. So we can write POS form is A bar plus B bar into what element of here A plus B. A bar plus B bar, which we can say AB whole bar into A plus B. Is this option is there? Yes, option C. The output now the circuit shown in the figure is, so here we'll get XOR gate now. So this is A XOR B. Next here, so this is A plus B bar whole bar. So what will come to be X, you tell me now here. A XOR B into what I'll get now. This is A bar into B now. Check karo. So this is what will come here. A bar B plus what element of here A B bar into what element of here A bar B. We multiply, see what I'll get to element of here A bar B plus what element of here A B bar. 0, sorry, this is if we multiply it, so a value तो 0 बनेगा ना. So finally हमको क्या मिलेगा, केवल a bar b मिलेगा. A bar b, option B. Yes, consider the following statements. NOR gate is equal to OR. Here, NAND gate, OR gate is nothing but a bubbled. NAND gate is nothing but a bubbled OR gate. NOR gate is equal to AND gate. Yes. NAND gate is equal to not outputs. Inputs are inverted. So yes, correct. A and B means 1 and 2. So option A. Next, for the circuit shown in the figure, F is, what will be the F? Yeah, this is X. So what you tell me now, X, XR with the X, which will be a 0. 0 and X. What is the 0 XR with the X? You tell me now here, X only. X, X. X, XR with the X, which is equal to 0. Next, the Boolean expression for the output y is. Yeah, tell me now here. Here directly a इधर आएगा and here a plus a bar. Okay, a plus a bar is a 1 now, so this is 1 directly given. So then why it should come to be a what terminal here a b c directly. Any combination circuit can be built by using NAND, NOR, and multiplexer. NAND, NOR, multiplexer are called as universals. 1, 2, 4. 1, 2, 4. Option D. MUX is also called as universal logic. And the function can be realized by using only a number of OR gates. So here, how much the n value? So how to implement the AND gate now here? So what we can say now here? Bubbled. Can say bubbled AND gate is nothing but what we can say is equal to NOR gate. So how many required? You can say 3 required. So you can see now here have taken AND gate we have taken. We have taken one NOR gate. A, B. So I have taken another NOR gate we have taken. These are connected here. So it will come to be a bar and this is B bar. So this is y is equal to what you tell me now here. So this is a bar plus b bar whole bar. Then y is equal to will come to be a what terminal here ab. So how many required now? 1, 2, 3. Next one. In the given figure, the output y equals which are the following? 8. So here we have this is AB bar. Here this is what terminal A bar B whole bar. Here this is A B bar whole bar. So finally y will come to be a what terminal here? AB bar into A bar B whole bar into A B bar whole bar. This is what terminal here? R gate plus. So you tell me what I will get now here. This is A bar plus B bar. This is A plus B bar. This is A bar plus B. Yeah, tell me what I will get. Yeah, A plus A bar is 1. So this is 1. 1 plus anything is 1 only. Yes, which one are the following is a correct output? This is A plus B whole bar. This is D bar. This is C plus D bar whole bar. So then F. Finally, F will come to be what terminal here? A plus B plus C plus D bar whole bar. So then F is equal to what we can say now here? A plus B into what I can say now here? C plus D bar. The option is what terminal? A. Next. Yeah, here will come to be X XOR Y. This is Y now. This also Y. This also Y. So will come to be X XOR Y. XOR with Y. Again XOR with Y. Now here this is X XOR with Y. Next XOR with X. XOR with what element of here? This is y. Now finally this output we required. So tell me the output y f, what will happen, you see. This is x XOR with y, XOR with what element here, y, XOR with y, XOR with what element here, x, XOR with y, XOR with x, XOR with y. So you tell me now here, x XOR with y, XOR with 0, and this is x XOR with y. Yes, yeah. So here this whole term I can say this is equal to 0. Same inputs now here. So here x XOR y, x XOR y. Same inputs, output is what will be 0 now. So finally this will come to be x XOR with y, XOR 0. So this is nothing but x XOR with y only. That's option A. Next one. Yeah, match the following. A, B. What will come? The bubble to NOR is a AND gate. Bubble to NOR. So this is one AND gate. Next here. Next. What else we have? Here NAND. NAND means what else? So bubble to is bubble to NOR. Bubble NOR is a AND gate. And so here and NAND gate. NAND gate is what a bubble to R. Where is a bubble to R? Yes, this is a bubble to R now. Next. And this is a 4. Bubble to NAND is nothing but R. So 2413. 2413. Option D. Yeah, I think this problem we did so many times. So here this is the AND gate. When the output of AND gate is 1, you can see this is the XNOR gate is given. So this is all the inputs must be 1. So C is 1 means B must be also 1. This also 1. B must be also 1. A must be 1. All are 1s. Option C. Earlier case they given this as what tell me one gate is a XOR gate, but here these two gates are XNOR only here. The output of a logic gate is 1 when all its inputs are at logic 0. This can be happens for the NAND and NOR case will happens. Next one. Yeah, this is what type of circuit we can see now. 0, 1, 0 stable. And if I given 1, 0, this is 1 stable. So this is a bistable circuit. How many inverters are there here? Number of NOT gates. So how many? Number of NOT gates. How many are there? Which we have it 2. So even number now. So it is bistable. Yeah. So this is A XOR B given as this thing. Look at now some A star. So they given as B, which is equal to what? Tell me now here. A bar B bar plus AB. What is this operation from this? Can you say this is nothing but what? A XOR B now? A XOR B. So from this, what we can conclude? You tell me now here. Then from this, they given C is equal to what? Tell me now here. A XOR B. Okay. What is this A XOR A? So if the same input case, XOR is output is 1 now. If this is C is equal to A XOR B, then so what will be the C XOR A is a which is equal to B. This operation will satisfy. Okay. Next, see the next one. They given the equation as what element of AB plus what element of A bar C which is equal to 1. Next AC plus B which is equal to 0. You tell me now for this case what will be the possible combination of inputs. what will be A, B, and C should be taken? I can definitely say that B must be 0. And uh, in this A and C may one definitely 0. If I have taken A is equal to 1, so check karo, this is 0. A 0, C1. Check this thing here. Satisfy. Yes. These are the input combinations. Next. What were the values of A, B, C here? They given the equation as A bar plus AB, which is equal to 0. So this is nothing but A bar plus B, which is equal to 0 now. Next, what is the other equation now? Tell me. AB, which is given as what? Tell me now. AC means B must be equal to C. Next, the given other equation is AB plus AC bar plus CD, which is equal to CD whole bar. Now let us verify the options. First, B is equal to C. Now I can eliminate these options here. Next one is what? A bar plus B 0. Yes, A bar plus B. It is satisfied now. A bar plus B. This is A bar. I think this won't satisfy. Next. Yes, next other thing is either A or C. You can see now here this equation AB. AB, which is equal to 0. AC bar is 1 plus CD, which is equal to 0. So this value 0 bar. Yes, this first one will satisfy. Next one. F1 into F2. If you do F1 into F2, common minterms will come now here. Which are common? Only 8 is common in these two. So what minterm will come here? So this is 8 will come here. Next F3 we have 8 common. No. What should be F3 so that F value given as what terminal here? 8 comma 9 I should get. Scalar this is which gate you tell me now here? R gate. Since it is R gate, so 9 must be high to ये वो पाएगा F3 में. Yes, option B. Like this we have so on we have. So then what can happen? If n is even, so if I say n is even case, we can simply check the n is equal to 2. So B XOR with B will come to be 0. Next, if I consider n is odd aito, so this is n value 3 le liya to, so this is B XOR with B XOR with B. So it will come to be a 0 XOR with B now. So it will come to be a what element of B only. Remains unchanged when n is odd. Next one. Yeah, tell me now here this equation which can be satisfied. First we can verify the simple equation xy equal to 0. xy. So then this option not satisfied now here. Next one. X plus y plus z is 1. This sum. Yes. This satisfied. This satisfied. This also satisfied. Next. Z plus w is 1. X into z plus x into z plus w. No, this is not satisfied. X into z plus double is satisfied. X into z plus no, this is not satisfied. Only this is the thing. Yes. Finally we have achieved our century. हमारा century complete हो गया. Yes. Our so many centuries are बाकी है. So the same manner you do follow the classes will continue in the next class. Okay then. See you. Bye bye.